Everyone. I hope you are doing good. So, the first thing we have to remember that you have to do your homework regularly because as we are not meeting in class, so I cannot warn you about that. So, I already posted some due date for the different assignments to make sure that you are doing the assignments properly. So, in last class we see that how we are doing with uh, 7.2. Then I hope you know how we are. So how we are doing solving problem and homework for 7.2. Now we are going to start 7.3 today. So it's nothing different than 7.2. So what we are doing for this? So the first thing, the one and only thing we will do for this chapter is we will find out is the specific data is it a normal data set or not. So how we are doing that? We are finding the expected z-score and we are plotting the expected z-score with the original values. And if we get a linear line, we draw a linear line when we so when we was doing scatter diagram, then we discussed what is linear relation will look like. So this will be the expected z on that side, and we will have the value on that side, on y-axis. Now, so if we have the graph look like this, suppose we have the points like that, then we will say this is our linear regression. This is our linear relation. Why? Because you can see all the points are on a single line, and this line indicates that all the points are on that line. So that's why we can see this is a linear line. So the thing we will do, so this graph, we are not creating this graph. So if you are asked any question like that, you will be provided by this graph. So you just need to notice how we are interpreting from the graph. Okay, so that's what we will do for this chapter. So what we are doing, we are finding the expected z-score. Then we are plotting the expected z-score with the values. Then we are looking, is it a linear relation or not? Okay, let's move on now. So you can see normal probability plots observe data versus normal score. That means expected z-score. So you can see normal score is the expected z-score. So if you remember when we was finding the z-score, the formula was something like that. Z is x negative mu over sigma. That was our formula for z-score. Now notice that we are not finding z-score, we are finding expected z-score. So what that is? We have a formula we are going to follow. Then we can find our expected z-score. So we discuss about that now. So let's see how we are going to find them. So we are following few steps here. The first step, what we are doing, we are finding the first step we are doing here. Okay, let me just give an example here. So the first step we are doing here, we are arranging the data set in ascending order. Suppose we have a data set which is T is one value, maybe we have two, maybe we have five, something like that. So if this is a data set we have, then the first thing we are doing, we are writing the data in ascending order. So you can see 2, 3, then 5. Good. So the second step we are doing, we are finding our Fi value. So the Fi indicates this formula. We are following this formula. And the I indicates the first value when So when we are doing 1, then I will take all the value we are doing here. So the data was something like that, 3, 2, and 5. So after ascending, we have 2, 3, 5, right? So now you can see this is our formula we are looking for. Then we are finding this value. So from here, I indicates we we have three values in this data set. We will get three value for A, F1, F2, and F3. And I will have three value. For that value, I is 1. For that value, I is 2. For that value, I is 3. Because I is the number or which number value is that. So this one is our first value after ascending. This one is our second. This one is our second value after ascending, and this one is our third value after ascending. So that's why those are the values for I, 1, 2, and 3. What about n here? N is the sample size we are discussing. So we have total three values, right? So that's why we will say the value for n is 3 here because we have sample size as 3. Then we will calculate the value of for f one by one using this formula. Then what will happen after finding this fi? So this fi, we will use that fi to find a z-score from table. Suppose let's calculate fi for the first value. So let's calculate f1. So f1 indicates that I is f1. That means that we are finding the value for first value. So which is 1. 1 negative 0.375 divided by, we have n is 3 for that case, and 3 plus 0.25. So when we are calculating that value, it will be, let me do it. So when we are calculating this value, this is 1 negative 0.375 divided by 3.5. So we are getting value which is very close to, let's change the color. So the value for F1 is 0.19. So 0.19. So this is the value for 0.19, right? So let me just write this value. So we are, so you can always go back to the video and look how we are finding this value. So this is going to be removed as I am changing the slides. So F1 value is 0.191. Sorry, 0.19. So how we are finding the value for Z? That means Z1. So we will find the value for Z1 using the normal curve. So how we are doing using the normal curve here? So let me show you. So 0.19, right? So here and let me right here 0.19, right? 0, 0.19. Now we are going to, how, where we have our normal table. So we have our normal table in the class material. So let's go class material. Okay. Normal table. So now we can see we have all the area we are finding here. So we are finding the exact point we find out for F1. So that was our value for F1. So this value indicates this, if this is V1, this value indicates F1 is the area on that side. Right? So that means the area on that side is 0.19. This is our F1. And we are trying to find out what would be that point, right? We are trying to find out that point, which would be our Z. So we know the area is 0.19. So we are trying to find out the area as 0.19 on that graph now. So let's see. We have 151. So we have 17, 192, 194. That one is the closest value we are looking for. I don't see any other closest value than 19, so which is 192. So we can take the value. Okay. So now what value we are going to take for what value we are going to take for this. So now from that point, as this is our selected point, from that point, okay, so up a little bit, so that we can see the value. Okay, so I need to see the whole graph. Okay. So now here, what we are doing, we are trying to find out how we are finding the value from the normal graph, right? So here, if we have our point, this is our selected point, right? So this is our selected point. From that point, so this is our selected point. From that point, we are going up. From that point, mm, so this is our selected point. Oh, this is something takes time. Okay, so that was our selected point. Now, what we are doing? So we are taking our selected point. We are looking at forward for the second digit after zero, and we are taking from here. We are taking our first digit. Oh, from here we are taking our second digit, and on that side we are taking our first digit. So the first digit is negative 0. The first digit after decimal is zero point 0.8, and we are taking the second digit after decimal from here, which is 7. So our selected value for z would be now z1 would be negative 0.8 and 7. This 7 is coming from here, and this negative 8 is coming from here. So if you can look at clearly, it will be higher here. So that's why we have C1 is negative 0.87, right? So let's go back to the slide now. So we have negative 0.87. So slide. So as I said, so we have now we have our F1 and we have our Z1, right? So 0.87. So let's try the value here so that we are not forgetting. Negative 0.87. So we know our F1 value, we know our Z1 value. Now, what we are going to do now? Now we have the Z score, we have the F value. Now we are plotting the observed value on the horizontal axis and the corresponding expected Z score on the vertical axis. So how we are doing it? So let me do it. Drawing here. So as we had our data, we had 3, 2, and 5. So that was our original data. After ascending we have 2, 3, and 5. Now what we are doing now? So that means the total we have. Suppose we are doing the rank. Hard to type draw here. So let's go back. So what we are doing now? The first thing we are writing rank. Then we are writing the value for x on the data value, right? X is the data value. Then we are writing the F1 value, Fi value, because it will be different for 1, 2, 3, and 4, 5. So then we are finding the Zi value. Now rank 1, 2, 3. We are taking 3 because we had only 3 data sets, which is 3, 2, and 5. So this is our data set. After ranking, we have the first data we have here, which is 2. The second data we have 3, and the last data we have 5. Then for the first data, we find out F1 was 0.19, and Z1 for that is negative 0.87. We look like this, we will find value for that point, that, and that using the formula, using the F formula, Fi formula, which is I negative, which is 0.375, 0.375, and N plus 0.25. So we are using that formula to find out F. After finding out F, this point, then we are using our normal table to get this point. You know how we are doing finding this value from our normal table. So if you're not sure, you can always go back and look what we did already. Right? Okay. So now come back here. So what we are discussing now. So now you can see we have our z value and we have our original value we discussed now. So now we are taking this value column and this value column. We are creating a graph. In this, we are taking z. Sorry, we are taking z on that side, which is z I, and we are taking xi on that side. Then we are drawing a curve using StatCrunch or Excel. But for that case, you don't need to draw the curve, you will already get the curve. Then you have to find out, is that a linear relation or not. If we have all the point on a straight line, then we are saying this is a linear relationship. If we don't have all the point on a straight line, then we are saying this is not a linear relationship. These two sideline is showing that how scattered they are. Now, the thing you need to know, we are finding the correlation coefficient between these two. So which two? We are finding the correlation coefficient between x and z. So why we are doing that? Because you can see we have x1 and z1. From there we have x and we have z. We are finding the correlation coefficient, which is r, which is the correlation coefficient between these two. After finding this, now we can go back to the slide and we can see how we are making the decision, are they linear or not. Okay, so as I said, what are indicates, what f and z indicates. Z indicates, as you already know, z indicates the point on that line. This is, if this is z1, maybe this one is z2, or z3, maybe this one is z5. So we don't know yet, but we are just guessing. So if this is z1, then from all the way to left to this point, this value is area, which we are saying this is f1, right? This value is f1. From that point to all the yes. Okay, so we already discussed about z1, which is f1 is area on that side. If we have a z2 here, then from all the way on that side, all the so from that point all the way to that side to the left, to that point, this area would be our area, which is f2, because this is our z2 point. So that's what this slide indicates. Okay, so now go to the next one, what we are putting there. So now you can see it says simplify. So what we are going to do, we are approximately finding a linear relationship or not. So we are trying to do a graph. So as I said, we are doing a graph between the data value and the expected z score, then we are looking at is it a linear relation, is it a linear relationship or not. Okay, so as I said, say we will have our data, we will have our data value, like we will have a data value x, and we will also have a value for z, right? Zi. We will have xi and zi. Then from these two points, we will find the linear relation, correlation coefficient. This. After finding the correlation coefficient, then we will look what is our sample size. And if the finded correlation coefficient is greater than any of if this critical value, then we are saying the linear the relation or the linear relationship is strong or significant. So how we are taking the relationship? So if we have, suppose we have n is 5, and we are find the area which is, sorry, this is 5, and sorry, and we are finding the correlation coefficient r is 0 point, suppose let's take 7. If this is 0 0.7, we are just taking random numbers. So we have the sample size n, and we find out the correlation coefficient between x and zi, and this is the correlation coefficient between x and zi. And make sure you find the z first, because z is the expected z score, which we need to find using the previous example, previous slide we just seen using that formula. Now, how we are taking decision from these critical values? So now we have sample size 5. Let's take 5. Now we can see when we have sample size 5, the critical value is 0.87, but we get our value is our zero point 0.7, which is smaller than the critical value. So that's why we will say the correlation coefficient, the linear relationship is not significant, or we can see this relationship is not significant. If instead of 7, if we would have 9 here, if we had 9 here, then we would say that as zero point 0.9 is greater than this critical value, so that's why we are thinking that the linear relationship between x and the linear z1 is significant. What does that mean when the linear when this correlation is significant? It does means that x is a variable, right? X is a variable. We are taking data from this variable. It indicates that this variable follows normal distribution, or this variable normally distributed. So what we are saying, so when this correlation coefficient is significant, or the uh, the graph from z and x follows exactly same line, then we are saying that the variable x follows normal distribution, or the variable x coming from a normal distribution. It's the same thing. So this is the thing we are finding by doing this test. This is not a test, but we are looking is that the variable x or variable y, whatever the variable is it normal or not? So that's what we are doing here. Okay, so and if you have any confusion, you can always ask me, or you can always find me in my office hour through Webex. So you have the Webex link in Blackboard. So you can always go to the Blackboard and click on that link. When I have my office hour, I will get a request from you that you want to join. Then I will accept you. Then we can talk about that. What is the problem and what you're facing? What the problem we're currently facing. Okay, so let's move down. So here you can see we have we have a data set. So you can read which kind of data set is that. So we have a data set, total 15 data sets, right? Now it says that is they are normally distributed or not. So how we are doing, how we are going to know are they normally distributed or not? So what we are doing, if we have StateCrunch or if we are using Excel or any other statistical software, then we can easily plug those data value in Excel or in any other statistical software. Then we can find out is that a normal distributed or not. But we need to know how software is working. So what they are doing, they are doing writing the data set in ascending order. So that means suppose we have the first thing is the number or the uh, number. So which number data is that? And this is our data. After that, we are finding our F value. We already know how we are finding our F value. And from F value, we are finding Zi for each of the F value. Suppose we have 15 data set, right? So we have number one, number two, and all the like this, we will have number 15 at the end. And we will have 15 X value because we are ascending the data set, and the first value would be what is the smallest value we have. The smallest value I can find, which is 6, 7, 8. So which is 6, 7, and 8. So for example, this one is our smallest value, right? So which is the first value for X. Then we are finding Fi using the formula, Then we are finding from there, we are finding our Z score. I already show you how we are finding our Z score. Then we will find the value for second value for Fi for the second X and Zi as well. So like that, we will get 15 pair of X, Fi and Zi or Xi and Zi. Now, then we are drawing a curve. So which sorry. Okay, so it should be so on that side we have Z and on that side we have the data value. Then if this is like this, then we are saying this is normally distributed. If you are given this graph, then you are taking decision from that graph. But if you are not given that graph, then as we are not learning how we are finding this graph, that way we are finding the R value. Forget my drawing here. So if we don't have, if we are not given the graph, then we are finding the R value for X and Z. So we are finding the R value between these two. You can always, we already know how to find out the R value. We did it in chapter 4. We use our calculator. So to find out the correlation coefficient. So we will get a correlation coefficient from there. This correlation coefficient, then we will look to our previous slide. Is it a significant value or not? If this is a significant value, then we are saying the data is normally distributed. The data set is normally distributed. You can see if R value is greater than the critical value, then we are saying the data set we are discussing here is normally distributed. Or if the R value we are finding here, if the R value is not greater than the critical value we will find from the table, then we will say the data set we are discussing here is not normally distributed. So the data set is normally distributed or not is the data set is X, because X is the data we are assuming that the data or data is X. So I hope this is clear because we are taking decision from R as well as from the graph. So if you are given the graph, then you will take decision from the graph. To verify, to make it verification, to you can always find out R and you can do the verification. Or if you are not given the graph, then you can always find the R from this Z and X. Then you can test the R is significant or not. If the R is significant, that means if the R value, whatever the value we will find here, if the R value is greater than the critical value, then we are saying the data is normally distributed. But if the R value is less than the critical value, then we are saying R value is not normally distributed. This is clear. You can watch it again and again if it's not clear. Okay, so let's move on. Okay, so here in the graph you can see this graph we are not using sorry, we are not using Minitab. So this is from Minitab. So the graph will look like this. So if you are given this graph, then you have to interpret from there. You can see here that all the data point is not on the line. So that's why we are saying this is not a linear. Uh, this is not a normal distributed data. So you can see we have box plot. We also can take decision from box plot. As you can see, this is too skewed data set because we have a uh, large portion of data on left side, and we as well as we have the outlier on left side. So this data is skewed left. So that's why this is not a normal distributed data. So we can easily assume from there. Then we have a data set from here. You again you have to find out the Fi and Zi. Then you have to plot it to find out if the data is normally distributed or not. So here you can see the plot. This value is normally distributed here because okay. So it's also depending on the R value. So I hope lecture is helping you to understand the class. So as we don't have any problems yet, so I will put a due date for um, so I will put a due date for the exam. Sorry, for the homework, and you already know when we are doing our exam and when we are doing our quiz. And please regularly check your homework, online homework. You are doing it. You are doing it. Make sure that you are doing it regularly. So try to be safe, and if you don't have any emergency, be at home. So this is an emergency situation. Okay, best of luck, everyone. See you.